Good afternoon, my dear students. Today we're going to have another virtual class for Math 6112. This is college trigonometry. Today we're going to discuss your modules in week 10, which is all about solutions of right triangle. Today is November 12, 2021, and our schedule is 1:10 to 2:40 p.m. So we have here the module 008, solutions of right triangles. One of the uses of trigonometry is in solving problems that involve a right triangle. In geometry, we learn about Pythagorean Theorem, but this is not enough to solve some problems involving right triangles. It is for this reason that we will explore the use of trigonometric ratios in solving right triangles. At the end of this module, you are expected to first use the Pythagorean theorem to solve right triangle. Number two, use the trigonometric ratios to solve right triangle. So this is now the formula in solving a right triangle. First, the Pythagorean theorem. Second, the trigonometric ratios. The third, your angle A plus your angle B is equal to 90 degrees. So this is now your Pythagorean theorem. The Pythagorean theorem states that the sum of the square of the legs of a right triangle is equal to the square of the hypotenuse. In other words, considering the right triangle below, then we have the relationship. So this is your right triangle with a right angle. This is your side A, side B, and side C. Four variables with small letters representing the three sides of a right triangle. So from your right Pythagorean theorem formula, c squared is equal to a squared plus b squared. So that is your Pythagorean theorem formula. And also, Pythagorean formula can be used only to solve for the remaining sides if there are already two sides that are given. So, if this is your right triangle, the right angle, which is 90 degrees, is always the opposite side of the right angle is always the hypotenuse side. Then, if you have the angle theta, let's say for this one is theta, your opposite side is your side A, and then your adjacent side is your side B. Okay? And if you have your angle here, alpha, which means the opposite side is your side B, the adjacent side is your side A. Side C is always the hypotenuse side, and it's always the longest side. Okay? So this means that if we know the measures, the two of the sides of a right triangle, then we can now measure of the third side by using the Pythagorean theorem. So this was side C. And if so happen that if we're going to look for the side B, B squared will be C squared minus A squared. And if we're going to look for side A squared will be C squared minus B squared. So those are the three formula in solving for the sides of a right triangle using Pythagorean theorem. So we have your example number one. We are going to solve for x. So this is your right triangle. There are already two sides given. So this is your side C and this is your side A from our figure. A and C are given. So therefore, you're going to solve for your side B, but by this time, your side B is equal to your side X. So using the Pythagorean theorem, x squared plus d squared, 12 squared is equal to 15 squared. Okay? This is your side A or side B, side A is equal to side C. So we have x squared plus 12 squared is 144 equal 15 squared is 225. So x squared is equal to 225 minus 144. 225 minus 144, that is equivalent to 81. So we're going to get the square root sign, x squared is equal to 81, your side x, the answer is equal to 9. So that is your example number 1 in solving for the remaining side of a right triangle if there are already two sides that are given. So next you have your D, trigonometric ratios in solving right triangle. So it says that to solve some problems involving right triangle, we will need more than Pythagorean theorem. We can also use the trigonometric ratios of the sides of a right triangle. We are already familiar with the sine, cosine, and tangent, but we'll look at them from a different perspective. To solve the right triangle, we can use the following trigonometric ratios. Sine theta is equal to opposite leg or opposite side divided by the hypotenuse side. Cosine theta is equal to adjacent side all over hypotenuse side. Tangent theta is equal to the opposite side all over the adjacent side. So we have your the acronym for this one. When you say sine, we have so, ka, towa. So, opposite hypotenuse, ka, adjacent hypotenuse, tangent, opposite adjacent. So to memorize it shorter, we have the sokatowa. And also we have your the kosyakaw. Kosyakaw is the reciprocal of sokatowa. For ko, which represents your cosecant, which means hypotenuse all over opposite. Siya, which means secant, hypotenuse all over adjacent. Kosyakaw, cotangent, which means adjacent all over opposite. So that is your 6 trigonometric functions. So notice that the starting letters of the terms are highlighted. This is the most commonly used way to remember the relationship between the trigonometric functions and the sides of a right triangle. So these are your acronym, SO, CA, TOA. Okay? Note that the words adjacent and opposite are relative to the angle being used. So let us look at the right triangle shown below. Okay? So we have your right triangle. There are three sides that are given. Okay? We have side 5, 12, and 13. So take note, a right triangle or a triangle is composed of 6 parts. The 3 sides and the 3 angle. Okay? So by this time, for this triangle, sine theta is equal to 5 all over 13. So it says that, note that the words adjacent and opposite are relative to the angle being used. So for this one, we're going to use your angle theta. So from your formula, sine theta is equal to so opposite all over hypotenuse. So we have 5 all over 13. Because of the leg opposite the angle theta has a measure of 5, while the measure of the hypotenuse is 13 on the other hand. So opposite all over hypotenuse. So that's now your first solution. Next, if we're going to solve for angle beta. Dito, pag sinolve natin yung theta, theta will be the same as arc sine 5 all over 13. So by using your calcu, we can have the value of your angle theta. So for sine beta, we're going to utilize this angle beta. So sine, which means opposite, 12 all over the hypotenuse, which is 13. So therefore, sine beta is equal to 12 all over 13. Because the leg opposite the angle beta is 12. So your longest side is always the hypotenuse side. Okay? So next, another example. Given the triangle below, solve for cosine beta and tangent theta. Okay? So from our formula, SOHCAHTOA. Solution: following the definition of the trigonometric ratios. Cosine beta, which means ka, adjacent all over hypotenuse. Okay? So with that, by looking at your right triangle, this is your right angle. The opposite side of the right angle is always the hypotenuse side. If you're going to utilize your angle beta, this is the opposite side, this is the adjacent side, and it's always the hypotenuse side. So cosine beta, adjacent all over hypotenuse, so we have 8 all over 17. Okay? Next, we have your tangent theta. So tangent theta is equal to opposite all over adjacent. We're going to make use of this angle, theta. Theta is equal to the opposite side is equal to 8. Then adjacent side is equal to 15. So that is our formula. So by using our calcu, 8 divided by 17, okay, then if we're going to look for the value of the angle theta, the answer is 25.20 degrees. That is your angle beta. Okay? If you have with you your calcu, okay, cosine beta is equal to 8 all over 17. 8 divided by 17 equal, then inverse cosine, the answer is, sorry for that, 61.92 degrees. And then, if we're going to solve for the tangent theta, we have 8 divided by 15, then inverse tangent, the answer is 28. Okay? So this one is 61 point something, and this one is 28 point something. And if we're going to add these two angles, beta and theta, it will give you a result of 90 degrees. Because your right angle is 90, so plus 61 point something plus 28 point something, you have a total of 180 degrees. So that is your answer. Okay? So that's the way how we're going to solve for the angle in a right triangle using your SOHCAHTOA. You have your another example. Given the right triangle below, solve for the value of your x and y, round off the answers the nearest hundreds. Okay? So with this, in solving a right triangle, there must be two given always. At least one of them is a side. So for this right triangle, there are two given. One angle and one side. We're going to look for the another side, that is your y and x. And if we're going to look on this right triangle, since the right one angle is already given, and we have your right angle, so we can solve for this remaining angle. If this is 20, this is 90, so therefore, the remaining angle here is equivalent to 70 degrees. So our problem is your y and x. If we're going to make use of this angle, if this is one given, so this is the opposite side, this is the hypotenuse side, and this is the adjacent side. For this time, we're going to solve for the hypotenuse side. So we're going to make use of your formula, sine. One way of solving this is by using the relationship within the sine of 20 and the sides 6 and y. So we have sine 20 degrees, opposite side is 6, hypotenuse side is y. So in this equation, the only unknown is y, because you can get the value of sine 20 using a calculator. Sine 20 is approximately equal to 0.34. So please don't use approximate value of sine 20. Apply some approximation rules on the final answer. Okay? So by using your calculator, y now is equal to 6 divided by sine 20 degrees. So therefore, the value of your y is equal to 17.54. Ito po siya, no? So meron tayong y which is equivalent to 17.54. Next, to solve for x, we can either use the relationship between 6x and the tangent 20 degrees, or we can use the value we get for y and apply the Pythagorean theorem. So let us try the first one. We're going to make use of your formula tangent 20 degrees. Tangent 20 degrees, which means opposite all over adjacent. Okay? So katawa, opposite all over adjacent. So with that tangent 20, your opposite side is 6, your adjacent side is equal to x. So we have x now, by cross multiplication, we have 6 all over tangent 20. By using your calculator, x is approximately equal to 16.48. So that's our side x and side y. Next, if you use another method, by this time, we are going to make use of your Pythagorean Theorem formula. So we have x squared plus 6 squared is equal to y squared. So since we already know the value of y, x squared plus 6 squared is equal to 17.54 squared. Ito po siya, no? Yung nakuha na natin yung y kanina. Ito, yung hypotenuse side. So by this time, naiwan na is your x. 6, 17.54. By using Pythagorean Theorem, we have x squared plus 36. For this one, 6 squared. 17.54 squared, we have 307.6516. So x is approximately 16.48. Of course, we expect to get the same answer for both methods. So by this time, you can have two solutions. Either using the SOHCAHTOA or by using the Pythagorean Theorem. So that's our solution for this example. We have two sides unknown and one angle given, with one side given. So next we have your another example. The kite of Amber got trapped in a hanging left of a 25 meters tall coconut tree. Assessing the situation, she realized that if she can place a long ladder such that the top end of the ladder will come in contact to the tree at a point 18 meters the ground, above the ground, then she would be able to reach the kite. If the ladder is 24 meters long, then what is the measure of the angle that the ladder makes with respect to the ground? Okay? So, we have your D illustration, no? So, merong mga given na data na dyan, no? So, meron kayong coconut tree po dito. Sabi niya, the kite of Amber got trapped in a hanging left of a 25 meters tall coconut tree. So, yung height po nito is 25 meters. Okay? That is 25 meters. Ang gagawin po ni Amber is kukuha po siya ng hagdanan. Ang haba niya is 24 meters long. Okay? Sabi dito, at the top end of the ladder will come in contact to the tree at a point 18 meters above the ground. Okay? Then she would be able to reach the kite if the ladder is 24 meters long. Ibig sabihin doon, magmula dito hanggang dito, that is 18 meters long. Okay? Tapos, yung haba ng hagdanan natin is 24 meters. Ang tanong ngayon, what is the measure of the angle that the ladder makes with respect to the ground. So this is your angle theta. So ito po yung hinahanap po natin. So by this time, we want to solve for the angle theta of inclination denoted as theta. The trigonometric ratio that involves theta is 18 and 24 is sine. Okay? So sine theta is equal to 18 all over 24. So the short theta, sine is equal to 18. Then we have 24. Opposite all over hypotenuse. Okay? At point 80 meters above the ground. Ibig sabihin, magmula dito yung 18 meters, no? Okay? So, by using this angle theta, opposite all over hypotenuse. So, sine theta is equal to 18 divided by 24. So, by using our calculator, sine theta is equal to 3 all over 4. If we're going to round off this one, since we're looking for the angle, we have to use the calculator such that what it gives is the angle whose sine is 3 all over 4. So for this time, theta is equal to 48.59 degrees. Therefore, the ladder must be placed such that it makes an angle of 48.59 degrees with respect to the ground. So, ibig sabihin, we're going to make use of 48.59 degrees para mabot niya yung coconut tree po dito, no? Yung 25 meters, ito yung buong natin, yung coconut tree po natin. Pero ang kailangan lang po niya, yung dito, vertical height is 18 meters above the ground. So this one is 24 meters. Pwede nyo isolve naman po dito, no? How far yung foot ng ladder dun sa foot ng tree po natin. So we have 24. That is our ladder, 24 squared. Okay? Then, minus 18 squared. Okay? By this time, we're going to have the value of the distance. That is equivalent to 15.86 for this side, no? So we have 18 meters, 24. This one, the distance of your ladder from the coconut tree is 15.87 meters. So that's our answer. Okay? So next we have the last problem. Three towns A, B, and C are connected by roads that form a triangle. The distance from A to C is 6 kilometers. And from B to C is 9 kilometers. The angle between these roads is 120 degrees. How far are the towns A and B from each other? Okay, so this is now our illustration. So there are three towns, A, B, and C. Okay, A to C is 6 kilometers. B to C is 9 kilometers. So this is now your illustration. The angle between these roads is 120 degrees. So magmula dito hanggang dito, that is 120 degrees. How far are towns A and B from each other? So A and B. If we're going to look on our figure, dun sa tatlong towns dito, we did not form a right triangle. So what we're going to do, we are going to project and form a right triangle para masolve po natin yung distance ng A and B. Okay? So by looking at your figure, if this one is 120 degrees, and if we're going to stretch that one, this one is horizontal line, we have a total of angle of 180 degree. This 120, the remaining angle here is 60 degrees. If this one is a right triangle, then if this 60, this one is 90 degrees. In order for us to solve distance A and B, we must first know the distance between your C and H. Okay? C and H muna. So, C and H, ito po siya. Pwede rin makuha ito, no? Ito. Yung H po dito. Okay? So, with that, we have now your right triangle. Right angle, 60 and 30. So, this one is your 9 kilometer, which represents the hypotenuse side, which is the opposite of the right angle. So, this one is angle 60 degrees. This one is the adjacent. This one is the hypotenuse. And this one is the opposite side. So, distance C and H, okay? So, we have cosine 60 degrees is equal to adjacent, then divided by hypotenuse, 9. So, therefore, your distance CH po natin, ito yung CH po natin, this adjacent side, cosine 60 is equal to CH, adjacent side, divided by 9, is equal to 9, multiplied by cosine 60. And also, if you're going to look for the distance BH, this one is the opposite side, and this one is the hypotenuse side. So, we're going to make use of sine. So, sine 60 degrees is equal to opposite all over hypotenuse. Sine 60, opposite all over hypotenuse. So, therefore, BH is equal to 9 multiplied by 60 degrees. And if we're going to simplify that, distance AB, okay, by using your Pythagorean Theorem. So, we have the total distance of this one is 6 kilometer plus CH. Okay? 6 kilometer plus CH, A squared plus B squared is equal to C squared. That is your distance A and B. Okay? So we have 6 plus 9 cosine 60 degrees for this one. Okay? Ito siya, no? Then plus 9 sine 60. This side. Okay? And then squared. So by using at your calculator, the distance between town A and B, we're going to have 13.77 kilometers. Yun po yung distansya po nila. Okay? So by this time, we have here an oblique triangle that we still solve using the right triangle. Kaya ang ginawa po natin para ma-solve siya is we're going to form a right triangle para magamit po natin yung sa katawa and at the same time, your Pythagorean Theorem. Okay? So, next, another example. A 5-meter long ladder leans against a wall with the top of the ladder being 4 meters. Ito siya, 4 meters. Above the ground, what is the approximate angle that the ladder makes with the ground? Okay? So, ito yung 5 meters pa natin. Tapos, nabot niya yung 4 meters above the ground nung hagdanan po natin. What is the approximate angle that the ladder makes with the ground? So, we are looking for alpha. Okay? With that, from our right triangle, this is your angle alpha. This one is the opposite side, and this one is the hypotenuse side. So, by using your trigonometric solutions, opposite, hypotenuse, so we have sine. Okay? So they've given me the opposite and the hypotenuse and asked me for the angle value. For this, I'll need to use the inverse trigonometric ratios. So sine alpha is equal to 4 opposite all over hypotenuse. So alpha is equal to inverse sine 4 divided by 5. The answer is 53.13 degrees. Therefore, the angle the ladder makes with the ground is about 53 degrees. So that's our solution. That's the way how we're going to make use of the formula, Pythagorean Theorem, and the 6 trigonometric functions. And if we're going to solve for this side, we can have that one. We have 5 squared is 25 minus 4 squared, that is 16. So by using this Pythagorean Theorem, this side is equal to 3. Okay? So next we have another problem. A tree 50 meters tall cast a shadow 60 meters long. So meron kayong ano natin dito, no? Meron kayong puno na ang taas ay 50 meters. Tapos nandito yung sun, nagkaroon siya ng shadow which is equivalent to 60 degrees. Ito, no? Find the angle of elevation of the sun at that time. So if we're going to look at our figure, this is our angle alpha. So if this is the line of sight, ang tawag po natin po dito, that is the angle of elevation. Pag nandito po yung line of sight po natin dito, ang tawag po natin doon, that is the angle of depression. Okay? So depende po yun, no? Pag dito, tignan mo siya doon, elevation. Pag dito, tignan mo siya doon, that is angle of depression. Since we're looking for this angle alpha, and the two parameters that are given is the opposite and adjacent. So we have the TOA, opposite all over adjacent. So tangent alpha is equal to 50 all over 60. So alpha is equal to arc tangent 5 all over 6. Alpha is equal to 39.80 degrees. So this is now your angle of elevation. Yung angle of depression po dito, that is 90 minus 39.80, that is around 41.20 degrees. And this one is 90 degrees. Okay? So that ends our discussion for today, which is all about the solutions of a right triangle using the Pythagorean Theorem formula and SOHCAHTOA, which is sine, cosine, and tangent. Thank you.